All right, I'm going to try and give you guys a quick lowdown on how to put numbers into scientific notation, as we talked about in class today. So the first thing you have to know, say we're going to deal with, say, the number 7,000. We're going to put it into scientific notation. What you have to understand first is that this is assumed times 10 to the 0. All right? Any number that you see, like this is assumed times 10 to the 0, and you have to assume that the decimal point is here. All right? That's assumed there at the decimal point. So I'm going to put this number in scientific notation. The rule is this: you can only have one digit to the left of the decimal point, and it cannot be a 0. All right? So I have to take this and I have to move it 1, 2, 3 spots, right? So it'd be 7. I have to move it here, so there's only one digit to the left of the decimal point. It's not a 0. So since I moved it to the left, this exponent has to increase. So if I move to the left 3 places, this exponent increases 3. So 0 increasing by 3 is times 10 to the 3rd. Okay? So that's that. So we have to remember that any number that you see, a whole number, or a number that you see without scientific notation, is assumed times 10 to the 0. If the decimal point moves to the left, the exponent increases. If the decimal point moves to the right, it decreases. So let me show you that real quickly. So if we have a number, let's do another example. If I have a number 0.00007, all right, this is assumed times 10 to the 0. Assumed times 10 to the 0. So I have to move this decimal point until there's only one digit to the left of the decimal point that's not a 0. So I have to move the decimal point to here. So I'm going to go 1, 2, 3, 4, 5. Right, it's being moved there to 5. So it becomes 7 times 10. This is assumed that 0 is going to decrease by 5. So that's going to be 7 times 10 to the minus 5. Okay? That's putting numbers into scientific notation. Okay, so let me show you how to multiply numbers that are in scientific notation. So here we have 5.2 times 10 to the 3rd. I'm going to multiply that by 2 times 10 to the 7th. So the first thing you do is just multiply these numbers here and here. Multiply these two numbers, right? I'm going to multiply them. So 5.2 times 2 is 10.4. Okay? What do we do with the exponents now? So now we have these exponents, we just add them. So add this exponent to this exponent. So 10 to the 3rd times 10 to the 7th is 3, plus 7 is 10. So times 10 to the 10th. All right? So that's how you do this. You multiply the numbers, then you add the exponents to each other. So now this is not a correct scientific notation. So remember, I have to have one digit to the left of the decimal point. So that means this has to move this way one spot. So you cannot change the decimal point without changing the exponent. So this ends up becoming 1.04 times 10. And since it moves to the left, the 10 increases by 1, 10 to the 11th. All right, so you cannot move the decimal point without changing the exponent, nor can you change the exponent without moving the decimal point. All right, so for multiplying, you multiply the numbers, right? 5.2 times 2, then you add the exponents. That gives us 10.4 times 10 to the 10th. And again, I have to put this in correct scientific notation, so I move the decimal point this way, 1. That's going to be 1.04 times 10 to the 11th. Okay, so now let's divide numbers that are in scientific notation. So similarly to multiplication, we're going to divide these numbers, right? So we're going to divide 4 divided by 8. So divide those two numbers, right? They're in front of the scientific notation part, so you're going to go 0.5 times 10. And now this time we're going to subtract the numerator minus the denominator. So you subtract the exponents. 10 minus 20 is minus 10. All right, so that's that. Just be careful when you're subtracting that you are doing your math functions correctly. So that's all that is. So, right, you divide the numbers and then you subtract the exponents. Always subtract the numerator minus the denominator. Okay, so this is going to be a mole conversion. So this is a concept that you guys are familiar with, just a different scenario. So a typical question may be something like this: how many mole are in 65 grams of carbon? So this is on slide 11 of the PowerPoint I attached. All right, so we always start off these problems with, we're going to write 65 grams. That's what we're starting with, of carbon. We're starting with 65 grams. Then in one motion, make your multiplication sign, your fraction line, and put grams of carbon down here, right? So as we did before when we were dealing with the metric system, right? Whatever unit is here goes here. I forgot the C, sorry. Right, so I start with the problem, with the number from the problem. I have 65 grams of carbon. That's what I'm starting with. I have 65 grams of carbon. I'm starting with it. So I need grams of carbon down here too. What am I looking for? I'm looking for moles of carbon. So I'm going to put mole of carbon right there. Okay? So if you're looking at slide 11, it tells you this. So now you have this number. These numbers are easy now. So no matter where in the fraction the word mole is, wherever the word mole is, you see the word mole, put the number 1 in front of it. Okay? Always put the number 1 in front of the word mole. Now if you see gram in the fraction, right, in the fraction part, you have to go to the periodic table and look for the atomic mass. So the atomic mass of carbon, we're just going to round it. The atomic mass of carbon is 12. So this number comes from the periodic table, the atomic mass. Right? You go to the element key, look for the atomic mass. It's usually the one with the decimal point in it. Okay? Then you just do the math, right? This cross cancels out, leaving us with 65 times 1, right? 65 times 1, right? Do not cross multiply. Do not cross multiply. 65 times 1, you don't multiply the numerators. We still have our moles of carbon over 12. All right, and now you would reduce that fraction. 65 divided by 12 is 5.4 mole carbon. Okay? So the key is do not cross multiply. You multiply the numerators and multiply the denominators, just like we did before. So this is assumed over 1, right? So 65 times 1 is 65. 1 times 12 is 12. Then you reduce it to 5.4. Okay? Again, this number comes from the problem. The word mole, when you're in the fraction part of this problem, of this equation, the word mole always gets number 1. The unit gram always gets the atomic mass of the particular element that you're looking at. All right? So in this case, it's carbon. Go to the periodic table. The atomic mass of carbon is 12. That's where those numbers come from. Okay, so now let me walk you through the problem on slide 12. All right, so it's the same situation. We're dealing with grams and moles. So this statement says, how many grams earn 6.2 moles of cobalt? How many grams earn 6.2 moles of cobalt? So again, I start with 6.2 mole of cobalt times fraction line, and mole of cobalt goes here. Right, get used to that pattern. Just get used to that pattern right off the bat. So that's the first thing I would do when doing these problems. I write down the number from the problem with the unit. Right, don't forget the unit. Whatever unit is here goes here. Right, so 6.2 mole of cobalt goes here. I'm looking for gram. All right, I'm looking for grams of cobalt. All right, so again, so now grams, that comes from the periodic table. So if you go to cobalt, CO, right in the middle of the periodic table, you'll see that it's 58.9 grams. We'll round that to 59 grams. All right, 59 grams. And the word mole always gets the number 1 in front of it. So this time it's in the denominator, right? So this time the 1's, so don't always put the 1 on top or always on the bottom. Wherever the word mole is where the 1 goes. So 1 goes in front of moles. Grams, you get that from the periodic table. If you look at cobalt, it's 58.9 grams. We'll just round that to 59 for now to keep the math fairly simple. So right now we just do the math, right? This crosses out. We have 6.2 times 59, which equals about 365 grams of cobalt. And that's it. All right, so the thing is just be careful. Again, wherever mole is, it gets the number 1. Mole may not always be in the numerator. It may not always be in the denominator. Right? It's determined by what we're starting with. We're starting with mole, right? From the problem, it says 6.2 mole. We're starting with mole, 6.2 mole. So if that's here, it belongs in the denominator. Okay? Compare that with the one we did previously. All right. Okay. Then why do we learn about scientific notation? For mole problems that include atoms. All right? So in this case, the problem says, how many atoms earn 6 moles of iron? So again, I'm starting with 6 mole of iron. All right, so I write 6 mole of iron times fraction line mole of Fe here. All right, now I'm looking for atoms, so I put atoms up here. All right, so what do I always put in front of the word mole? The number 1. All right, so 1 goes here. So what do I put in front of atoms? Well, if you remember, when we talked about 1 mole, a mole is an amount. So how many are in a mole? Just like a dozen was 12, a mole is 6.022 times 10 to the 23rd. All right, so that's why we learn scientific notation. So whenever you see atoms, you put Avogadro's number in there, right? Because 1 mole is equal to Avogadro's number. So 6.022 times 10 to the 23rd goes in front of the word atoms whenever you have that in the fraction, right? So when we learn how to do this, 6 times 6.022, right, comes out to 30, well, this cross cancels out, right? So this is 36.1 times 10 to the 23, all right? But now that's not in correct scientific notation, so if you remember, we have to move this decimal point this way. So this is going to be 3.6 times 10 to the 24. If we move to the left, the exponent increases by 1. All right, you can't just move the decimal point without changing the exponent. All right, so that answer would be 3.6 times 10 to the 24. All right, so I think it's slide 15 kind of gives you the summary. Slide 15 will give you the summary of all the different scenarios. So always, 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 whatever you have in your problem statement, right? 6 moles of iron, so I'm starting with, it's the first thing you write on paper. Whatever this unit is, has to be the same unit down here, right? So whatever these words are, has to be these words, all right? And then, so moles always gets the number 1. Grams always gets the atomic mass, which you get from the periodic table. And then atoms always gets Avogadro's number in front of it, all right? So that should be it in a nutshell.